The tracking station here is dominated by 4 large dishes. A giant 70-metre dish called Deep Space Station 43, the largest antenna dish here in the Southern Hemisphere, in fact one of the largest antennas in the world for spacecraft communication. There's also 3 34-metre diameter dishes, and all of these antennas are capable of talking to spacecraft hundreds of millions, billions of kilometres away.
The DSN has been my life. It's been my entire career from coming out of college. And the beauty of the industry, it's a continuously renewing. There's always something more interesting, more audacious coming along, and it's just on a ride, you know. So you jump on, and it's guaranteed to satisfy. You know, in my career, I've tracked every deep space spacecraft in the last 30 years. The Cassini's going into Saturn, I was there. You know, so Voyager around Neptune, I was there. And I ticked them off, and all the landings, I was there. And I believe I played a part in it. And that's where you can't help but feeling quite proud.
We currently have 40 different missions out across the solar system, 8 just studying the sun. We have another 8 missions studying the planet Mars, with things like the Curiosity rover, which has been on the surface of the planet now, exploring that world for the last 8 years. We had missions like the Cassini spacecraft, which spent 13 years exploring Saturn, bringing back stunning images and data about that ringed world and its amazing moons, some of them which might even support life in some oceans below the surface. And of course, we're still tracking, after 43 years, NASA's twin Voyager spacecraft, which made the big journeys to go to Jupiter, Saturn, Uranus and Neptune, and now leaving our solar system. Voyager 1, the most distant spacecraft, over 22 billion kilometres from home.
The last couple of years, things have gone crazy in the space industries, especially Australia. So we've certainly, after years of sort of inactivity, we've certainly had major buy-in now. There were many years when we were the only public-facing space industry. So, I mean, Australia's been in the space industry for a long time, but we were probably one of the most obvious.
When we tend to think of space, we tend to think of NASA, going out and doing their exploration. But a lot of people don't think of Australia being a spacefaring country. But we have an industry here already that employs over 12,000 people in different areas. We're exporting about $4 billion a year in technologies and services overseas, so we're actually a key player. I think for Australia, we're also all about that remoteness. We're separated from the rest of the world by incredible distances, even in flight or communication time. So we're used to that idea of the remote. So that's why we're really good at our communication work here. But we're also good at inventing, coming up with new ways of doing things. You know, we invented the Hills hoist, we did the pop-up toaster, we do all these amazing things, the rotary engine and so forth. That kind of inventiveness, that capability to think outside the box, that's what Australia's good at. New ways of doing things, and space exploration is all about new ways of doing things, surmounting what seemingly is the impossible. And that's what I think our future is going to be, helping in the exploration of the other planets through new technologies, new ideas.
This is one of 3 around the world. You've got the Canberra Operations Centre, you have one in Madrid as well, and one in Goldstone. And we're actually running Follow the Sun, so we will control the network. So from this room here, we're controlling the antenna in Madrid and Goldstone, as well as our own. And so later on this afternoon, we'll hand over to Madrid, and they'll do the same thing.
When we explore space, a lot of people tend to think that we're sort of putting money in a tin can and chucking it overboard when we get up there. But all of that expenditure, all that effort to explore space is all about learning more about our own planet, our place in the universe. We always talk about the possibility of finding life on other worlds. Well, that's not just to find aliens, it's to actually learn, how does life begin? What is the uniqueness of human beings on this planet and all other life on this planet? Are we alone in the universe? So we're just answering some fundamental questions about who we are and why we're here. We all ask that sort of thing in our lives at some time. But we're also, by doing that exploration and pushing the bounds of what's possible, doing these seemingly incredible things on other worlds out there, we're also creating new technologies, new processes, new ways of doing things. Pretty much every aspect of our lives is affected in some way by our exploration of space, whether it's just getting the weather report from tomorrow or just using Wi-Fi. came from space exploration, or things that we use in our hospitals or in our schools, in our cars. It's in every aspect of our lives. So we do it to explore, but we do it to actually benefit everybody here on Earth.
Because I'm in an industry that thrives on discovery, and so whether it's a robotic exploration mission, and so we've got one coming up to Europa as well in a couple of years as well, so or a human mission. So I suppose it's bang for your buck. You know, the shuttle was incredibly expensive, but you know, you look at the likes of some of the Mars missions, the Europa Clipper being launched in 2 years' time, Juno around Jupiter at the moment. So they're not a particularly expensive sort of instrument, and so brings back incredible science.
The Canberra Deep Space Communication Complex will actually play a significant role in the Artemis missions. To send astronauts to the moon, you need a rocket, you need lots of training, you need people on the ground, but you have to have a communication system in between, and that's what the tracking station does. We can send commands and voice communications to the astronauts. We can check on the health of their spacecraft, on the experiments they might set up on the moon. They can get all their information and news back. We can do all the tracking just to get them there and get them home again. So that vital communication path, that's what the Deep Space Tracking Station does, and what our great team of Australians here from the CSIRO do every single day with robotic missions. We're doing it with human missions in the future.
By 2050, I reckon we will have a human on Mars. So I also think that the way we communicate would have changed with it, so possibly more optical. We'll also have probably more ambitious missions going out to the Jovian planets and Saturn planets as well, because there's so much we don't know out there. And so at the moment we're just sort of concentrating on the planets themselves, and every one of the little moons is an ecosystem of its own, and so that will be really exciting. And yeah, it's whether we stop at Mars, and you know, there's talk about sort of humans on asteroids as well. So, and I suppose the only thing stopping us is budget. So, but if somebody has I don't know, vision, so then I think we could get there.